Let's talk about this term hydraulic conductivity in a little more detail. We know that in Darcy's law, the flow through a porous media is bigger when the hydraulic conductivity is bigger. Those two things scale proportionally. But what is this K really telling you about? Is it telling you about the water, or is it telling you about the sand? Is it telling you about something in particular to Earth or to Mars, for example? So it turns out that hydraulic conductivity is a property that actually depends on both the fluid in question, namely water in this case, and on the porous media. Water. So K really just refers to water and the media. And let's see if we can build some intuition for this. So you can imagine that if you were trying to push water through a tube, if that tube was filled with gravel, for the same push, it would be a lot easier to push than if it were filled with sand versus silt versus clay. Because the pore sizes are getting smaller and smaller, there's less pore space, you're having to take a more tortuous route. So the flow rate's going to be bigger through the tube with gravel, so K is going to be bigger in the gravel than it is in clay. And just a note, this is interesting, K for common materials at Earth's surface varies by more than 10 orders of magnitude. It's one of the physical parameters that varies the most in earth science in common applications. So there's more than a billion-fold difference in K of common Earth surface materials. So this is why you may have heard this saying that K puts the geology in hydrogeology. It is what is describing the rocks and how easily water flows through them, for example. So that's the properties of the media, but we know that K is kind of a function of water. So you could imagine, for example, that if you were trying to put something through a tube, consider, for example, honey versus water. The fluid itself is going to determine the flow rate. It's going to be a lot harder for you to put honey through this tube versus water. And so K specifically just refers to water. But we might be curious to know, is there some other parameter that is more generic, that doesn't depend on the fluid, but just depends on the porous media? And the answer is yes. And the answer is this term little k, lowercase k, which is known as the intrinsic permeability. And so it's independent of the fluid. You could be talking about honey, you could be talking about water, you could be talking about gas, independent of the fluid. So it's just a function of the porous media. It has dimensions of area, length squared, and so you can kind of think of it as it's related to the porosity, but of course the tortuosity, or the path that water flows, matters as well. And we can relate big K hydraulic conductivity to little k through the following relation. I'll use a different color here. So big K is equal to little k times rho g over mu. And so this is the density of the fluid. More dense, bigger. This is Earth's gravity. And this term here is the dynamic viscosity. And so, for example, we know that honey is much more viscous than water. And so that's how that term comes in here. And so this is the way in which we can relate K, which really just refers to water. So it's describing the properties of the water, but also the porous media, to this other term, little k, intrinsic permeability, which is really just describing the ability of the porous media to transmit a fluid, regardless of the nature of that particular fluid.